To session 4 of model 3. In the earlier sessions, we are discussing about what about the non-uniform flow. Under that, what is gradually varied flow, rapidly varied flow, and also we are discussing about the under rapidly varying flow, what is hydraulic jump, the situation at which hydraulic jump is occurs, and applications of the hydraulic jump and derivations which use the relationship between sequent depths as well as uniform discharge, and then continuation of the particular equation, that is the relationship between sequent depths to the Proud's number means y1, y2 and f, and also we are deriving equations related to the loss of energy HL, and also we know how to find out the height of the jump, length of the jump, and all these things. And also in last session we are solving some of the problems related to the hydraulic jump and all these things. This section is continuation of the previous one. Once again, in the hydraulic jump chapter, there is equal weightage for derivations as well as problems. Therefore, I try to discuss some of the problems related to the hydraulic jump. Water flows at a rate of 1 meter per second along the channel of rectangular section 1.60 meter in width. Calculate the critical depth. If a standing wave occurs at a point where upstream depth is 0.25 meter, what would be the rise in water level produced and power lost in the standing wave? The hydraulic jump is also termed as a standing wave, since for few seconds or few minutes the waves are stationary at the point of hydraulic jump formation. That's why it is also called as standing wave or standing wave. So in this problem, we have to find out the critical depth. Critical depth is one where the specific energy is critical, that is YC, where EC is minimum. It is also termed as EC. So what is given is given the discharge is given capital Q 1 meter per second. Width of the channel is given 1.60 meter, and depth of flow before hydraulic jump is given, it is 0.25 meter. So first you find out the discharge per unit width. Discharge per unit width. Discharge per unit width. Q equals capital Q by P. So capital Q is 1. Width of the channel is 1.6. So it gives 0.625 meter cube per second is the discharge per unit width. So once you know the discharge per unit width, next we pass on to the find out the what about the critical depth by using the specific energy equations. Specific energy equations. The formula used to find out YC or DC, critical depth in a specific energy, equals cube root of Q square by G, small q square by G. From that, it is possible to find out the what about the critical depth occur for the given data. So it is around 0.341 meter. 0.341 meter. What about the value of D1? D1 is I think 0.25. So YC is greater than Y1. So hydraulic jump is occurs. This is the condition. Another condition. Other than Proud's number, it is possible to find out whether hydraulic jump occurs or not on basis of the This is find out by using the formula d2 equals d1 by 2 plus d1 square by 4 plus 2 square by g d1. Here we know d1, here we know q, here we know the g value and all these things, and substitute, that is 0.25 by 2 plus square root of 0.25 square by 4 plus 2 into 0.625 is small q, which are for unit, divided by 9.81 into 0.25, it is around 0.453 meter. So again, 0.453 meter is greater than critical depth. Definitely it should be more than critical depth only. Even if you are getting less than YC, then somewhere you are wrong. Verify the answer. Okay, before you go for solving the problem, you are thinking these things, because if the idle jump occurs, definitely the value of y2 is greater than yc. Here y2 is greater than yc, therefore idle jump is occurs. Rising water level is the difference between the y2 and y1, otherwise d2 minus d1, or difference between the idle jump after jump and before jump. So it is comes under 0.203 meters. Velocity before jump, velocity before jump is q by d1, or q by d1. D1 is given 0.25, it is 2.5 meter per second. Velocity after jump, q by d2, 0.625 by 0.453. 0.453 is the value of y2. So substitute, you get 1.38 meters per second is the velocity of the jump. Specific energy at before jump, E1 equals E1 plus V1 square by 2. So we substitute, you get the value of specific energy before idle jump is 0.568. 0.658. And specific energy at after jump equals E2 equals D2 plus V2 square by 2. So substitute, you get 0.550. So loss of it due to friction is possible to find out. It is difference between specific energy after jump minus specific energy before jump. That's all. Or difference between the specific energy of before jump and after jump. So you substitute E1 minus E2. So we get 0.018 is the loss of it, where 0.568 is specific energy before jump, 0.550 is the specific energy after jump. So we get the value of 0.018. And also it is possible to find out the loss of it by using the d2 minus d1 or 2 by 4 d1 d2. It is also possible to find out. This is another way of find out the head loss due to jump. So power loss is find out W2 into HL by 1000. Substitute it. Okay, so you get 0.177 kilowatts. Is the power lost. Here we are substituting in terms of newtons. Next we consider to the another problem. Water flow in a rectangular channel 0.60 meter wide at a depth of 0.18 at a crowd number 2.75 is given the crowd number before jump. Find the specific energy at and the critical depth, sequence depth, head loss due to idle jump, and power loss. So in this problem is given the value of crowd number itself. So before jump is supercritical. Definitely it is more than 1. So flow is supercritical only. So is given B, width of the rectangular channel is 0.60, depth of flow is 0.18, and F1 is 2.75. Means the before jump flow is supercritical since F1 is greater than 1. So once you know the value of F1, from that it is possible to find out the value of V1. Route number can be equals or route number equals F equals or F1 equals Q1 by 2 G D1. So we know D1, we know F1. From that you find out the value of velocity of flow before atomic jump. It is somewhere around 3.654 meter per second. Once you are find out the value of V1, so it is possible to find out the specific energy before atomic jump. E1 equals D1 plus V1 square by 2G. So here we know D1 0.18, we know V1 3.654, we know G 1.81. Substitute it and get the value of discharge per unit width. Discharge per unit width. So Q equals d1v1. So we know d1, we know v1. So we get 0.658 meter per second per unit. Unit means per meter. So once you know the value of Q, so then it is easy to find out the what about the critical depth. dc or yc equals cube root of q square by g. So we substitute the value of q square, q and g and get the critical depth is 0.353. It is greater than d1. Greater than d1. I think d1 is 0.18. So therefore it's okay. Hydrogen is factors. Sequent depth. Sequent means depth after the jump. Using formula d2 equals d1 by 2 into square root of 1 plus 8 f1 square minus 1. We know d1, we know f1 value, substitute it and get the value of 0.616 meter. y2 is greater than yc. So it satisfies the conditions of hydraulic jump. Head loss, hydraulic jump. d2 minus d1 whole cube by 4 d1 d2. We know all the parameters, so substitute it and get loss of head is 0.187 meter of water. So power loss equals WQ into HF by HL by 1000. Substitute it. Here small capital Q stands for discharge in a channel, full channel width of 1.6 meter, not a unit discharge. Be careful. So it is 0.65 into 0.6. So we get around 0.697 kilowatts is the power loss for this given data. That is overall is very important. This is related to the sluice gate. Water issues out under the sluice gate. Sluice gate is a gate usually placed above the crest of a dam or a spillway or the weir to increase the storage capacity. If the excess of water is entered into the reservoir, then automatically they allow the water to reach the downstream side below the sluice gate, where hydraulic jump is occurs. The opening of which is 0.25 meter deep in a rectangular channel through which flows at a discharge of 1.10 meter per second per unit width is directly given the value of small q. Taking cc function of contraction is 0.60, determine if the hydraulic jump occurs. If so, determine depth after the jump and loss of energy due to jump. So in this problem is asked to find out the what about the depth of flow after jump as well as loss of energy. First, you find out the what about the depth at unit contraction. Unit contraction is a point where the cross-sectional area of flow is minimum. Okay, unit contraction is a section where the total cross-sectional area of the flow is minimum. So once it is reached the minimum, afterwards it goes on increasing. So unit contraction is the minimum cross-sectional area of place or point usually is 0.6 into 0.25. 0.6 to 0.25. So here is given the CC value. That's why 0.6 into 0.25 it gives 0.15 meter. Velocity at unit contraction. Once again, integrated equation. V1 equals Q by D1. Right? D1. So we know Q, we know D1. So it is 1.1 by 0.15, 7.33 meter per second. So once you know the value of V1, once you know the value of D1, so it is possible to determine Gauss number. F1 equals V1 by root GD1. We know V1 7.33, we know D1 0.15, and substitute it, you get the value of Gauss number is 6.045. It is greater than 1. See, that means greater than 1 means it is supercritical flow. So hydraulic flow occurs. So if it is greater than 1 means the type of flow is supercritical flow. So once we know the value of F1 and conclude hydraulic jump occurs, then you pass on to the what about the sequent depth after the jump. So V2 equals D1 by 2 into minus 1 plus square root of 1 plus 8 F1 square We know the F1 value, we know D1, substitute it and get 1.210. So it is value of D2 or Y2. Loss of it due to add or jump is D2 minus D1 whole cube by 4 D1 D2. You know D1, we know D2. I substitute, we get the value of loss of head due to add or jump is 1.641 meter. Next problem is in a rectangular channel 0.75 meter wide, a hydraulic occurs at a section where the depth of water is 0.2 meter. This V1 is 0.2 and the Froude number is 3. This F1 is 3. Okay, determine specific energy head, critical depth, sequence depth, loss of it, and power loss due to jump. Here is the value of B 0.75, D1 0.2, and F1 is 3. It is greater than 1. Automatically, it is supercritical flow. So, first you find out the value of V1. We know the value of F1 and B1 and all these things. So, F1 equals V1 by root GD1. We substitute it and velocity before I jump comes around 4.202 meter per second. So discharge per unit weight of channel small q equals V1 into D1 equals, we know V1 4.202, we know D1 0.2, substitute it, we get 0.8404 meter cube per second per unit weight. So you have to find out the specific energy head. Specific energy head E equals D1 plus V1 square by 2G. We know D1 0.2, we know V1 4.202, and we know G 9.81. Substitute it, get the specific energy head is 1.10 meter before hydraulic jump. And critical depth DC or YC both are same. Q root of Q square by G. We get 0.416. 0.416. It is greater than Y1. So hydraulic jump definitely occurs. So depth of the jump using the formula D2 equals D1 by 2 into square root of 1 plus 8 F1 square minus 1. We know D1, we know F1 and all these things substituted, get 0.7544. It is greater than YC. This satisfies the conditions of hydraulic jump. The sequence depths are, finally it is better to conclude the answer 0.2 meter and 0.7544 meter, and head loss is 0.2823. Head loss is as usual D2 minus D1 O2 divided by 4 D1 D2. For loss due to jump WQHL by 1000, we get 1.745 kilowatts loss of power loss due to hydraulic jump. Next one, a supercritical flow with a Froude number of 3.15 exists in a channel of rectangular section. A hydraulic jump is to be formed to dissipate an energy head of 2 meters. Determine the sequence depth. This problem is somewhat different. He is already given that the hydraulic jump is occurs and also is given the value of F1. Okay, and also energy dissipated is given, it is 2 meters is given. So he has to find out the sequence depth. So we know the formula T2 by D1 equals 1 by 2 into root square root of 1 plus 8 F1 square minus 1. So from that it is possible to find out the ratio of D2 to D1. Okay, so it is comes around 3.983. Okay, and hydraulic last hydraulic jump HL equals D2 minus D1 whole cube divided by 4 D1 D2 is given. Energy dissipated and the energy head is 2 meter equals 2. Okay, so you simplify the particular one. So HL by D1 equals D2 minus D1 whole cube divided by 4 D1 square by D2 equals 2 by D1, and further simplification we get D2 by D1 minus 1 whole cube divided by 4 D2 by D1 To further simplification and all these things, we get d1 equals 1.194 meter. 1.19 meter. So the value of d1 is 1.194. d2 is, we know d2 by d1 ratio is 3.983. So 3.983 into 1.194, we get 4.757 is the value of d2. Next problem is the loss of energy in hydraulic jump is 4.25 meter. The road number just before the jump is 7.5, which F1 is 7.5. Find discharge per unit width of channel, the depths before and after jump, route number after jump, percentage loss of energy at due to jump, and length of the jump. So is given E1 minus E2 is 4.25. Energy at loss of energy at, and is given the value of F1 7.50. So is asked to find out the remaining things. So d2 by d1 equals 1 by 2 into minus 1 plus square root of 8 f1 square. Substituted. Okay, so d2 minus d1 is d2 is explained, but d1 is 10.12 d1. 10.12 d1. So actually equals d1 minus d2 equals d2 minus d1 whole cube divided by 4 d1 d2 equals 4.25. Plus 4.25. So we substitute this one d2 in terms of d1. d2 can be done as 10.12 d1 minus d1 whole cube divided by 4 into 10.12 d1 square equals 4.25, and further simplification we get the value of d1 is 0.227. So d2 equals 10.12 d1. So substitute d1 is 0.227. We get the value of d2 is 2.297. So you know the equation. Okay, the relation between d1 d2 as well as q square by g d1 d2 equals d2 plus d1 by 2. To substitute the value of d1 d2 and find out the value of small q plus small q is discharge per unit width. It is comes under 2.541 per second. So F1 equals 7.5. Okay, and we find out the value of V1. You know D1 is 0.227. So substitute it. Get the value of V1 is 11.19 meter per second. You know continuity equation. D1 V1 equals D2 V2. So we know D1, we know D2, we know V1. To find out the value of V2. So substituting the value of V1, D1 as well as D2, we get the value of V2 is 1.106 meter per second. Once you know the value of V1, V2 and all these things, D1, D2 and all these things, it is possible to find out the specific energy before jump, specific energy after jump. So E1 equals D1 plus V1 square by 2g, and substitute we get 6.61 meter. D2 equals D2 plus V2 square by 2g. Substitute the value of D1 and D2 and V2, we get 2.36 meter. So then finally we apply the check. Anyhow is given, loss of it is 4.25. We know E1 E2. E1 minus E2 is 6.61 minus 2.36, which gives 4.25. Hence it is correct. It is checked. The route number after jump is F2 equals V2 by root G D2. So substitute it, we get the value of 0.233. And he is asked to find out the what about the percentage of energy, loss of energy due to jump. So is given in terms of percentage. So which gives the value of percentage means E1 minus V2 by E1 into 100. So he's asking to express in terms of percentage loss of energy. So which gives around 64.3%. And length of the jump is, it is varies from 5 to 7 of height of jump. So here is taken as 7 d2 minus d1. So length of the jump is 14.49. Thank you.